Today, we're tackling a powerful ML tool, support vector regression. All right, let's jump right in. Most models try to get every single error down to zero, but what if a model just didn't care about small mistakes?
And that's the whole idea behind SVR. It's all about finding a simple fit that works within a certain margin of error.
So SVR basically draws this boundary, this tube around its predictions. Think of it as its don't care zone. Any data point that lands inside this tube, the model just says, good enough, and gives it a zero penalty. Yep, zero. So the only points that actually matter are the ones outside this tube. We call these the support vectors. And because of this focus, SVR is great with outliers and super memory efficient. Pretty cool, right? Okay, so that's great for straight lines. But what if your data is all curvy and complex? Well, this is where SVR pulls out its magic move, the kernel trick. It projects the data into a higher dimension where a simple flat plane can now separate it. Pretty clever. These projections are done by kernel functions. The RBF kernel is your go-to, but others have specific jobs. All right, so we get how it works, but how do we actually control it? Meet your main controls, C, gamma, and epsilon. Think of them as the tuning dials for your SVR model. First up, C. Low C means a simpler, smoother model. High C means the model tries to fit everything. Then there's gamma. This sets how far a single data point's influence reaches. Low is global, high is local. Okay, so you open up scikit-learn and see 3 types of SVR. Which one should you actually use? SVR is your versatile go-to. New SVR gives you finer control. And for big data and speed, pick linear SVR. But wait, before you do anything else, there is one absolutely non-negotiable step you have to take. You have to scale your features. SVR is all about distance, so big numbers can totally throw off the model. And hey, don't just take my word for it. The docs are clear. Scaling isn't optional, it's essential. So let's recap. SVR has an error tube, uses kernels for curves, gets tuned by hyperparameters, and always needs scaling. SVR is clever because it ignores the easy stuff. So here's a thought. What other problems could we solve by just focusing on the exceptions?